So far, we've just been talking about simple variables, and we're not going to get into this right now, but we will soon. If you're familiar with programming in other languages, particularly R in my case, you're aware of the fact that just single variables by themselves can be useful, I guess, in some situations, but really when you're doing some heavy duty processing, you want to assemble a collection of data values in some sort of a organized structure, like a spreadsheet. Spreadsheets are a good analogy because everybody uses them and understands the utility of having a lot of data in an organized fashion like that, where, with Excel, you have to, columns are of a similar type, I believe, but rows are not. Well, you have the same thing in computer languages as well, and Python's no exception. You have sets, you have dictionaries, you have lists, and you have tuples, and they're each structured in different ways and indexed in different ways to make each one appropriate for certain types of tasks. So we'll get into this before too long, but with data structures, you can greatly extend your processing capabilities. I mean, so just keep that in mind. And the other thing that I wanted to mention, Python, like R, has an incredibly rich source of information in the public domain. I joke around about using Dr. Google, but I think you'll find that if you do any programming in a open source language like Python, that whatever problem you're having, somebody has already had, and you can do very precise Google searches and find fixes for things that are going wrong in your case. Okay, so that's another good thing about Python. Okay, so let's see, where were we? Let me get rid of this. Make sure I don't close up. Okay, so we were still talking about for loops, and this is slide 32, I think. Yes, it is. Okay, so now we're going to look at break. And again, I like Murak's approach. I like how he starts at the beginning, and he starts out at 0 miles an hour and slowly goes up to 30 miles an hour by introducing a basic concept and then building on that. And also his use of the yellow highlighting parts of the code that are new and interesting, I think is instructive and useful. Okay, so here we're just looking at the break statement, and break, we previously mentioned that you can just simply, instead of having a Boolean expression here, you can just put in the Boolean variable, which is a Boolean expression that evaluates to true. You can just say, well, true, which will cause this loop to go on forever and ever. So how do you get out of it? Well, in this case, if the user is entering data here with this input statement, if they enter exit, the string EXIT, then that will trigger this condition to be true, and therefore the subsequent statements in that if block will get executed. In this case, break. And what break does, it causes the while loop to exit. Okay, so what does this little program do? What does it do? It asks for you to enter an integer, and notice, okay, because we are allowing the person the ability to enter an integer to square it, and an integer is a number, of course, but also we're using the same input statement to provide the opportunity for the user to type exit, which is not a number, exit is a string, that we separate the input statement itself and the coercion of that data into an integer down here, right? So at this point, data, if they enter in a string, everything will be fine. Here, let's do this. And I've jazzed up a little bit by putting this line up top. So we run this and it tells you enter exit when you're done, enter an integer to square. So every time we enter an integer, it simply squares it. If we enter exit, of course, then the break statement is executed and it goes out and exits the loop altogether. On the other hand, we can try this again. And we say, see what happens when we enter a real number. No, it doesn't. Okay. It doesn't like the real number. And so we get a runtime error down here. Let's try it one more time. This time we will enter a string other than exit. Again, another runtime error. Okay, so the program's not going to work unless you do enter either an integer or a the specific string exit. Okay. So now, so in this example, we're looking at the break statement specifically, but there is a corresponding continue statement. Whereas what break does, break will, in this case, okay, so look at this program. So we've got an outer while loop, and then within that outer while loop, we have an if statement nested within it. Whereas break would cause the outer while loop to end, continue forces it to start over again. Continue changes the control, in this case, to the second line. So you go back up here. So the continue statement continues a loop by causing execution to jump to the top of the loop. And this causes the loop to execute again by reevaluating its condition. So let's do this. And what are we doing here? We're doing some pretty simple data validation, rudimentary, where if the person enters miles driven less than 0 or gallons used less than 0, it just gives you this canned response. Both entries must be greater than 0. Try again, but notice that you go back up to the top of the loop, right? And if they do enter legitimate values for miles driven and gallons used, it's going to compute the miles per gallon by dividing miles driven by gallons used and rounding that to 2 decimal places, and then printing that out. And then only after that, giving the user the opportunity to enter more valid data and start the loop over. Okay, well, what does that mean? Well, so this is 2 ways that you can cause the while loop to continue, right? You can explicitly use the continue statement, which will take you back up to the top. Or in this case, and this is very common, we're using waiting for the user to input yes, either uppercase Y or lowercase y, to instantiate the value of this variable more and start. So this will always be true. If you enter in uppercase or lowercase y, this will always be true and you'll never get out of the loop again. Okay, so let's do this. So we run it, miles driven. 250, valid data, gallons of gas, 15. So this is the case where they entered valid data, and we go down here and give the user the opportunity to enter yes. Note if you enter anything other than lowercase y or uppercase y, it will end. Okay, so it's not really working in the best way. Okay, if you present the user with something like this, you say yes or no, the program should only accept that, should only accept a yes or no, which in this case it doesn't. Or if we, let's run it one more time, make this big so we can see it, inner miles driven minus 170 miles. Notice it allows you to enter both of them before it checks for the valid data, and we'll enter 0 for gallons of gas. This invokes the continue statement, and again, just forces it to go back to the top of the while loop until you finally do enter something valid. Continue. In this case, we'll say no, but again, anything other than uppercase Y or lowercase y will cause the program to end. Okay, so that's what break and continue do. What would happen if we didn't check that? Well, because of the nature of this program, of course, and particularly here, where we're calculating MPG, this denominator, if we entered 0, this expression doesn't make any sense. You can't divide by 0. So, and that's frequently the error that you'll get if you don't initialize variables. In this case, we do it with user input immediately, but you can't divide by 0, which is a very common error that you'll get. Okay, so that's that. Okay, so this next one is a little bit more computationally specific. And what does that mean? That's the one we just did. So here we are calculating the future value of a one-time investment, and we're doing it same thing in 2 different ways. We're using a for loop up here, and we say they invest $10,000 and just leave it in the bank for 20 years in this case, and they earn a 5% return on their investment every year. So yearly interest first year would be 500, then it would be a little more than 500, and that keeps getting added to the principal. So we compute, it walks through this range, which actually is going to be start at 0. It's going to be 0 to 19. And just keeps adding the yearly investment, the yearly interest to the original investment with this statement. And then when it finally exits out of this for loop, after doing it 20 times from 0 to 19, it's going to take the current value of investment and round it to 2 decimal places. And the while loop does the same thing, and notice with the while loop, again, we're initializing both year and investment. And while year is less than 20, this will, again, year will be 0. We're incrementing in the loop. We increment year by 1 every time it goes through the loop. These 2 lines of code are the exact same as in the for loop. So year will start out at 0, 1, 2, 3, 4, up to 19. And then again, we compute the investment. This is on 2 different scripts in the script folder. One of them looks like this.